Hi everyone, in this lesson I'm going to show you how to manipulate reading for a rectangular glass prism. All you need to do is to get a triangular glass prism. This is a triangular glass prism which will be provided for you for the experiment. A single optical pin. In the experiment you are supposed to be providing 4 optical pins, but in this experiment you just need 1 optical pin. You need a protractor. You also need a ruler. You can make use of set squares if you want to, but if you don't need them, if you don't want to, you may use your protractor in place of that. Then you have your pencil. These are the basic materials that are required. So let us read through the instructions. You are provided with a rectangular glass prism, drawing board, drawing papers, optical pins, and thumb pins. Using the diagram above as a guide, carry out the following instruction. Trace the outline A, B, C, D of the rectangular glass prism on a sheet of paper as shown above. Remove the rectangular glass prism. So let us quickly draw the outline A, B, C, D. So this is my outline. So I'm going to label this just the way we have it here. A, B, C, D. So this is going to be A, B, C, and D. Next is to mark a position N very close to A and draw a normal MN arrow at N. So this is N, which is closer to A than B. So this is the normal MN arrow. So I'm going to draw that now. So how do we draw that? So you are going to use your protractor, locate a point close to A, put a dot there. Let's say this. So I will not be needing my set square. So I'll just place this mark. Take note of this mark here. This, place it on top of this, and ensure that this mark stays on the line. So this is 90. I will mark this. So following the diagram, from the diagram you can see that MN passes through N and ends at R. MN passes through N and ends at R. So I'm going to draw this with a ruler from here. Draw this down to this point. So this is M, N, and R. 3. We are to draw a line TN to make an angle I equals 20 degrees with MN. So this is TN. This is angle I, which is 20 degrees. So this angle is going to be 20 degrees. That is MNT. So we are going to draw that. Get your protractor. This is your protractor. Place this mark on this point. Then measure 20 degrees from 90. So you know that from here to here will be 70, from here to here will be 20. So I'll just put my mark at the 20 cm mark here. So having done that, I'll join these two together using my ruler. So I have this and this joined together. So this is line TN with TNM or MNT equals 20 degrees. Now the next thing you have to do, you don't need to place this back because the instruction is fix 2 pins at point P1 and P2 along TN, along this line, but you don't need that. So all you need to do is this. So after that, you have to replace the rectangular glass prism on its outline. Fix two other pins at points P3 and P4 such that the pins appear to be in a straight line with the images of the pins at P1 and P2 when viewed through the rectangular glass prism from side. This is so from this side. When you view from this side, you are supposed to put this here, but you don't need that. So what you need to do is to know the refractive index of this glass. So for this my glass, the refractive index is 1.5. So I'm going to do this. Since my refractive index is 1.5, I have n equals 1.5. Now remember the formula. So I'm going to do this for all of them. Remember the formula, n equals sine I over sine r, where sine I, or where I is the angle of incidence and r is the angle of refraction. So from here you can see that sine r equals sine I over n. So in all of these, we are going to be looking for sine r equals sine I over 1.5, because that's the refractive index of the glass. So what I will now do is this. Now the angle of incidence here is 20 degrees. So I'll simply do this. Sine r equals sine 20 divided by 1.5. So I'll do this using my calculator. I have sine 20 divided by 1.5. That's going to give me 0.228. So r is equal to arc sine 0.228. So I'll just take the arc sine of that angle. So I press shift sine 0.228. So that's going to give me 13.1 degrees or 13.2 degrees, which is close to 13 degrees. So what I'm going to do is this. I'm going to take my protractor, I'll turn it upside down like this. I'll place it on this point here. So I'm going to read 13 degrees. So this is, I'm sure that this is on 90. So I'm going to read 30 degrees from this place. What you simply do is this. Since you are moving like this, I'm going to have 90 minus 13. That will give me 77. So at 77 degrees here, this is 75, 76, 77 here. So I'll just place this here. Then I'll join this line to this point here. So that's all I need to do. Now, in this diagram, there is no normal on this other side, but you have to create a normal here. There's no normal here, so I have to create a normal. How do I do that? I'll just place this on top of this and mark the 90 degrees here. Once I've marked the 90 degrees here, you can trace it out with just dotted lines so that they don't meet. Now I have this. Okay, let me trace it upward. So this is my normal. Now this angle here is equal to this angle. Remember that from my calculation, this angle R is 13 degrees. So this angle is also what? 13 degrees. So I have to look for this other angle here that the refracted ray or the emergent ray is going to make with this angle here. So what do I do? Now remember that for glass, now this is air to glass. Now from here it's going to be glass to air. So the refractive index from glass to air, is now equal to sine I over sine E. This is the emergent ray. So what am I looking for? The emergent ray. So remember that the refractive index, refracted from glass to air is equal to 1 over refractive index air to what? Glass. So that will give us refractive index is equal to 1 over 1.5 equals sine I over sine E. So all I have to do is just divide this. 1 divided by 1.5, that will give me 0.667 equals sine I over sine E. So here I'm going to have sine E equals sine. Now sine I is 13 degrees. The angle that we had here, this angle here, which is equal to this. because they are alternate angle, all over 0.667. So sine E equals, so I'll just take sine 13 divided by 0.667. So that will give me 0.337. So E is going to be arc sine 0.337. So that will give me shift sine that will give me 19.7 degrees, which is the same as 20 degrees. Now you will find out that the emergent angle is always equal to the angle of incidence. So there's no need for you to be doing this all the time. So the emergent angle here is equal to the angle of incidence. So what I will just do is just come to this place, turn this upside down again. I'll place it here, and I'll measure 20 degrees from here. So that will be at 70. So I'll place it like this. Then I'll join these two lines together. So I'm joining these two lines from here to here. I'll join them together. So I have this. So that gives me my emergent ray. So what I will just do now is to take my pin. See, you see it now. Haven't done this. Just come to this place. Place this here. Place a point here. Place another point here. And place another point here. Now, like I said that there is no need for you to be doing this. I just wanted to show you with this that the emergent angle is always equal to the angle of incidence, because it's just the same interface from air to glass, glass to air. So from there, from the instructions, we are asked, so after that, remove the glass prism, draw a line to, okay, we have done that, join NS. So this is N, and this is what? X, so which we have already done from our manipulation. So the next thing is to measure and record distance NL, NS equals L. So this is NS equals L, and RS equals Q. So we have a space to put this. So my reading is going to be like this. I'm going to draw my table based on what I have there. So I'm going to have this serial number. So we have to measure, record L in cm. L is in cm. Then we measure Q, also in cm. Q is in cm. Then we have to evaluate sin I. So I have to put a column for sin I. Okay, I think I'll make that somewhere. There is I there, so I'm going to put my I here. I in degrees, so my serial number should be on the other side. So I have serial number, then I have sin I. There's no unit for that, just a constant. Then I'm going to evaluate Q over L. Q over L. Then I'll have this. There. So this is what I am over evaluating. There's no unit for Q over L because L is in cm and Q is also in what? Centimeter. So when I work them out, they are going to cancel out. The units are going to cancel out each other. So the first one is 20 degrees to 1 decimal place. So we can now measure L. So my measurement here is going to be on this. So I have this 0. So I have 6, 5, 1, 2, 3, 4, 6.4. 1 decimal place. It's called direct measurement, 6.4. And I'm going to measure Q. Okay, from here. So this is L and this is Q. So I'm going to measure Q. So this is going to be, this is 5, 1, 2, 3, 4, 5, 1.5. So Q is equal to 1.5. We can leave the evaluating and go for the other. So now we have done that. Now the next step is to 10. Repeat the procedure for I equals 30 degrees. So I'm going to repeat that procedure for 30 degrees, then I'll pause the video and do for all others. So let me measure 30 degrees. So I'll place my compass here, my protractor here. So I'm going to get 30 degrees away from 60. So I'll join this. So this angle is 30 degrees. So again, we are going to apply the formula. So here you are going to know that R is simply going to be equal to arc sine of 30 degrees divided by 1.5. So you can just press this from your calculator, shift, sine, open a bracket, sine 30 divided by 1.5, then close the bracket. So that's going to give me 19.5 degrees. So my angle of incidence is going to be 19.5 degrees. So I'm going to turn this upside down, place it on top of this, ensure that this is on the 90, this line and this line. So I'm going to measure 19.5. So from my calculator, I just do, because this is 90, I'm going to do 90 minus 19.5. That'll give me 70.5. So I'm going to put it at 70. This is 70, just midway between 70.5 there. So I'm going to join this point to this. So having done that, I'm going to draw a normal here again. So I'll place this here, place on top of the line, and this is 90. So I'm going to draw an imaginary normal here, using broken lines. So I'm going to have this. So the emergent ray is the same as this. So I'm going to measure 30 degrees from here. So I'm at 60. So 30. So I'm going to join this. So the next thing for me to do is to get my pin again. Just place one here, place the other one here, place one here, and place the other one here. So I have done for 20 degrees, 30 degrees. So join me as I complete all others. Okay, let me take the measurement for this. So this is going to be, I have 0, this is going to be 0, 0, I have 6.9. So I'm going to record that as 6.9. And I'm going to record Q. So my Q is measure and record Q. This is 2.1, 2.2. So I have 2.2. So this is 30.0 degrees. Now we have that. So let me complete all others. So these are the readings that I've generated from 1 to 4. So I am going to generate the reading for the last one, which is angle 60 degrees. So let's get this done. So I'm going to measure 60 degrees from here, the same way. So this is going to be 60 degrees. So this angle is 60 degrees. So I'm going to join this. Then the next thing we have to do is to calculate the angle of refraction. So number 5 is going to be equal to arc sine 60 degrees divided by 1.5. So that's going to give us sine 60 degrees 0.866. So I'm going to do shift sine 0.866 divided by 1.5, close the bracket. That's going to give us 35.3 degrees. So the angle of refraction is going to be 35.3. Of course, it's going to be difficult to get 35.3, so I can just approximate to 35 degrees. So that's going to give us 90 minus 35. That's 55. So I'm going to place that 55 here. I'm actually subtracting because we are going this way and we are measuring, taking our angles this way. So I'm going to join this from this same point. So I'm going to join this. This is going to be this. So the angle of emergence is going to be 60 degrees also. So this is 90. So I can just take my 60 degrees from here. This is 60 degrees. So I'm going to draw this. So I'll draw this. Now, so I have to use my pins. 1, 2. 1, 2. So we're done. So this is what is required. So the next thing for me to do is to measure this as usual. I'm going to measure L. So my L is going to be 0 as 8.0. So I have 8.0. Then my Q is going to be 4.6. 4.6. Now we are asked to evaluate this. Now it is common knowledge. If you look at this, Q is actually opposite. Why this is the longest side? It actually means that we are asked to look for sine, the sine of this angle here. The sine of this angle is opposite over what? Hypotenuse. So this evaluation Q over L is actually the sine of the angle of what? Refraction. These are basic things that you need to know. That is what they want you to do. So I will do this. So sine 20 degrees. The angle of incidence is 20 degrees. So I have sine 20 degrees. That's going to give me 0.342. I'm going to evaluate this to at least 3 decimal places. So I have 0.342. So I'm going to 342. I'm going to evaluate all others this way. So these are the evaluation of the sines of the given angles here to the at least 3 decimal places because you are evaluating. Now these are direct measurement to 1 decimal places. I measure this directly, so I give them rounded up my figures to 1 decimal places, and this I have to round it off to at least 3 decimal places. Then for this, it's also an evaluation, so I have to evaluate it to at least 3 decimal places. So what I'm going to do, 1.5 divided by 6.4. 1.5 divided by 6.4, that will give me 0.2343. So I'm going to add it to 0.234. 0.234. So I'll do this for all others. Now these are the values that I've evaluated for Q over L. If you take these angles, if you take these values and take their inverse trigonometry function, you will get this approximately these values that we have here. The values that we calculated for arrow for 1, 2, 3, 4, and 5. You should try it out. Let me say shift sine 0.234. So I have 13.5, which is approximately equal to what we had here, which was 13.2 for the angle we measured. So this shows that our manipulated values are actually what? Correct. So this is that. If you can try for the other ones, let me try for the last one. Shift sine 0.575. That will give me 35.09. Here my approximation was, my evaluated value was 35.3, which is also very close to what the value we had for our calculator. So next is to plot a graph of y on the vertical axis and sine I on the horizontal. I forgot to add this Q over L is actually what? Q over L is actually what? Y. So the evaluation Q over L is giving us Y. So I'm going to place this here as Y equals Q over L. Now to plot the graph, we are going to look at these values here to plot the graph. So we are plotting Y on the vertical axis, then we are plotting sine I on the horizontal axis, starting both axes from the origin. So we have to start both axes from the origin, 0, 0. So it means that since we are starting the, both graph values from the origin, it means that we have to ensure that we fit all these values into this and this place, starting from what? 0. So now let's get these values. Let's see how we'll be able to plot this graph. So let's look at these values. The lowest value here is 0.2 and the highest value is 0.1. So if I take a graph of, if I take a scale of 0.1 unit to 2 cm, it's going to be enough for us. Let's see, if I start my graph from this place, I want to try as much as possible to make use of all the space on the graph sheet. That is what I want to do. I want to try as much as possible to use all the graph, or at least 2/3 of the space. So if this is 2 cm, the gap between two of them is 2 cm. So if this is 2 cm, so I'm going to have, let's say, if I start from 0 here, 0.1, 0.2, 0.3, 0.4, 0.5, which is going to 0.6, which is going to occupy this. So if I decide to extend it and make it 4 cm to 0.1 unit, I'm going to have 1, 2, 3, 4. That is 0.1, 1, 2, 3, 4, 0.2, 1, 2, 3, 4, 0.3, 1, 2, 3, 4, 0.4, 1, 2, 3, 4, 0.5, and I have 0.57. So if I have 0.5, I'm going to have 0.55 here, which is not going to be enough for us. So what I'm going to do is to try and stretch it out a bit. Let's see, 1, 2, 3, 4. I'm going to make it 0.2, 1, 2, 3, 4, 0.4, 1, 2, 3, 4, 0.4, 1, 2, 3, 4, 0.5, 1, 2, 3, 4, 0.6, which fits into the values for us. So I'm going to, on this graph, I'm going to take a scale of 4 cm to 0.2 unit. Now for the, so I can start my graph from this once. So let me draw this. So on this axis, on the y-axis, I have taken a scale of 4 cm to 0.2 unit. Remember, there is no unit for y, so this is simply y. So I can put it up this way, or I can put it this way, and this is going to be sine I. So that is sine I that way. So I'll have to take the scale for that again. Now on the sine I axis, I have taken a scale of 2 cm to 0.1 unit. So you can see that the units with the gap between them is 0.1 unit. Now the reason why I did that is because the least value here for sine I is 0.3, while the highest value is 0.866. So I extended it to 0.9 on the graph. Starting this from the origin, I have 0.1. Now there is one important thing I want you to take note. So on the y-axis, I'm going to do something. On the y-axis, the gap between them, for easy reading of values and easy marking out of points, there's a simple logic that you have to apply. Now let's look at this. The gap between this point and this is 20. This is 5, 10, 15, 20. So you note that down. And now the numerical value between this and this is 0.2. So what I'm going to do is this. I'm going to divide 0.2 divided by 20. That's going to give me 0.01. So let me note this down on the y-axis. So what it means is that on the y-axis, each of these smaller lines have a numerical value of 0.01. That is what they mean. Then on the sine I-axis, please, you are going to note it and just write it down. On the sine I-axis, the gap between this and this is 20, and the numerical value between this and this is 0.1. So I'm going to do 0.1 divided by 10. The gap between them is 10, so that will also give me 0.01. So the gap between this and this, so each of this line is 0.01. Each of these lines, yes, they are 0.01, and each of the single line here is also 0.01. Now we are going to make use of them when we want to take readings from this. Now let's look at this. Let's plot the point. The first point is 0.3424 sine I and 0.234 for y. So now let me trace out 0.234 for y. Now this is 0.234. The nearest value to 0.324 is 0.22. So what you are going to do is, from your calculator, just press 0.234 minus 0.2. That's going to give me 0.0034. So what I'm going to do is to divide it by this number that I have placed here, this 0.01 divided by 0.01. That's going to give me 3.4. So it means that I'm going to move 3.4 places from 0.2. So this is 1, 2, 3. Of course, I cannot get 0.4, but I can just place it between a small place between this. Now you get that for easy reading, I've been able to trace out this value out of this instead of wasting my time trying to count it out from the value. Now let's go to, now let's go to the sine I-axis. I have 0.32342. So the closest value to 0.342 is 0.3. I'll do the same thing. 0.342 minus 0.3. That's going to give me 0.042. I'll still divide it by this number here, 0.01 divided by 0.01. So that's going to give me 4.2. So I'm going to move 4.2 places from 0.3. So I have 1, 2, 3, 4. So this is the point. So what the next I have to do is just trace them out. Trace this upward. I'm going to move it up to this point here. So I have easily read out this point. I'll mark it and put a 0 set. So that is the point of intersection of those 2 points. Now I'm going to do the same for the next value. Then I will draw other values while I pause the video. Now let's look at this. To read off 0. For the sine, for the y-axis, I have 0.319. 0.319. Now the closest value to that is still 0.2. It's still 0.2. This 0.2, so minus 0.2. So I have 0.119 divided by this number here, 0.01. So that's going to give me 11 plus 0.9. So I'm going to move 12 places from 0.2. So I have, this is 5, this is 10, 11, 12. So I'm going to move this way, 12 places. Then let's go to this, 0.5. So I have 0.5 exactly on this point. So I just read it off, trace it up, and move it to, the point I pointed out here, which is this. So I'll mark it and put it on top like that. So let me take, so this is it. This is the point here. 0.5 is directly on top of this. On top of this, I'll move it up to this point, then trace it to this point that I marked here. So this is, it gives you, it makes it looks easy for you to read or determine your points. Now, for 0.408, the closest point is 0.4. So I'm going to subtract 0.4 from that. Then I'll divide it by 0.01. So I have 0.408 minus 0.4 divided by 0.01. So I have just one place. I'll just move one place from this. What I have here is 0.1, which is not up to 1, but I will just move one place from this. So this is this point here, 1. So I'll have to trace out 0.643. So I have 0.643. The closest point on 0.643 is 0.6. So I have 0.643 minus 0.6. That's 0.043 divided by 0.01. So that will give me 4.2. So I have to move 4.3 places from 6 here, from 0.6 here. So I have 1, 2, 3, 4. So I'll just trace it up to the point that I marked beyond 0.4, this 0.4 to this point here. So I'll mark it. So that is how I will do it for all others. So for the last part, I'm going 0.575. So the closest value to 0.575 is still 0.4. So 0.575 minus 0.4 divided by 0.01 is going to give me 17.5. So I'm going to move 17.5 places from 0.4. So this is 5, 10, 15. This is 17.5. So I will note the place point down here. I can place my ruler on top of that place to read it off to the other side. Now the next one is 0.860. So the closest number to 0.860 is 0.8. So I'm going to have 0.866 minus 0.8. That will give me 0.066 divided by 0.01. So that will give me 6.6 places from 0.8. So that will be close to 7 places from 0. So this is 0.8. I'll just move 1, 2, 3, 4, 5, 6, 7. So I can go between 6 and 7. Then move it up, trace it to this point here. So I have my point here, and I place my circle here. So the next thing for us to do is, so these are the points, is to get a line of best fit. Let's see how we get a line of best fit from this. So if I take this, you see that these two are way outside. So my line of best fit can fit into these 3 lines here. Now when drawing your line of best fit, don't make the error of starting it from the origin. You're going to make mistake. Always fit it with the line at the point that you know that is going to fit best within the graph. So I'm going to do this. So I'll draw this. Now this ends here. So if I need to join it to this other side, I have to extrapolate by using broken lines for this. So this is the graph. Then from there, we are asked to determine the slope of the graph. So how do I determine? If I can take any point on this and draw a large triangle from it. So I'm going to do this. So I draw a large triangle on any point on this. So to read out my slope, I'm going to do the same thing that I've been doing. Okay, to read off values from here, we are still going to make use of these our values here, these 2 values. So let me read this off. I have this point here. Now I'm going to count. This is from this point, this is 4. So I'll count it up, or this is 4. So I have from 4 this way I have 5, 10, 15, 16, 17. So what I'm going to do is this. I'm going to multiply 17 by this number here, 0.01 times 0.01. That is 17 times 0.01. That is 0.17. So all I need to do is to add that to 0.4 here. 0.17 plus 4, that gives me 4.17. That's 0.417, because what I have here is 0.04. So I have 0.417. So I can come to this place and record that down. So the slope is equal to 0.417 minus, then I'll go down to this point again. So this side is exactly on 0.2. So I'm going to record 0.200 to 2 decimal places divided by, so I'm going to read the values for x. So this is exactly midway between 0.8 and 0.9, so that will be 0.85. So I have 0.85, 0.850, my 3 decimal places minus, then on this, the closest number here, the closest value here is 0.3, so I just have to count 1, 2. That is 1, 2. That's 2 times this number again, 0.01 times 0.01. That's going to give me 0.02. So I just have to add it to 0.3 plus 0.3. So that gives me 0.320. 0.320. So this is going to give me 0.417 minus 0.200 as 0.217 divided by 0.850 minus 0.320. That's going to give me 0.53. So let's evaluate the 0.217 divided by 0.503. That will give me, that's equal to 0.409. So that has to evaluate K. There's no unit for that because this has no unit, this has no unit. Equals S inverse. S inverse is simply 1 over N. That's 1 over 0.409. So 1 divided by 0.409. That gives me 2.4. 2.44. So that is my evaluation. For the precautions, you can state so many precautions. One of them is to avoid error due to parallax when using meter rule, your ruler, when using your protractor. Another one is that you ensure neat traces. Another one is that you ensure that your pins are spaced out evenly. There's not too much large space between them. And another one is to ensure that they are vertically always erect. Then we have some theory questions that are added to them. Distinguish between dispersion and refraction of light. Dispersion has to do with separation of the colors of white light when they pass through a triangular prism, while refraction is just the bending of wave when it travels from one medium to another. Then this one you can calculate the refractive index of this and so on. So that is the much we can take on this. Thank you for finding out time to watch this video, and I hope that it is helpful. If it is, please subscribe to our YouTube channel, which is U Science Lab.